different people with different expertise. So we can just kind of go around just to see. So Mariana, so could you explain your general experience with software and coding and what you know so far?
Well, hello guys, my name is Mariana. I have a little bit of experience with Python. I've been learning Java. I'm not pretty good, but I've been learning as an autodidact for part of the team. And that's it. I would say that.
Okay, that sounds good. That final?
I have some experience with the autonomous software that we've been using, but I've also been practicing a little bit of Java while I have free time, which also helps.
Okay.
And I don't know how to explain stuff, so that's it.
Yep, okay, that's good. I know, Rafael, you've been working on the software for a while, so I'm gonna try to tailor this lesson to look to everyone to make sure everyone understands the best they can. And Nathaniel, how about you?
So I have quite a bit of experience with Python and game development, and I'm currently on my journey to understand Java better as a whole.
Alright, that sounds good. Elise?
I have no experience at all, but I kind of wanted to learn because it looks interesting, so.
Yeah, for sure.
Got this.
And Shane?
I just have a little bit of Python experience.
Nice.
That's about it.
And I have no experience whatsoever.
That's perfectly okay. Before I initially tried joining the programming team, I had no experience with Java either, so that's perfectly okay. So don't let that be a roadblock in your way into learning software, because everyone started somewhere, but it's really good that you guys came to this workshop to learn more about it. So basically, the first question I wanted to start with, so you guys have all seen these joysticks, right, that we use to control the robot?
Yes, I use.
So what do you guys think actually happens if I, let's say, press a button on a joystick?
It would perform a specific function relating to the coding of that specific button.
True. Yep, exactly. So that's how it works. If you don't know the software, if you're just getting into it, it seems like, oh, I'm pressing something and the robot magically works, right? But there's a long process that happens. So firstly, what we have is what we use to control our and check our robot status is a software called driver station that you guys can see over here. So here we have our three main things. So currently everything's red because we don't have a robot, but they still mean the same thing. So communications means whether you're actually connected to the robot over Wi-Fi. That's how we transfer code. And it's also how we're able to communicate with the robot. So if you don't have communications and you press something, the robot's not going to do anything. And robot code, this makes sure that the robot actually has active code it recognizes. If this is red, you need to redeploy code and transfer code over again, just to make sure your robot knows. And the joysticks is basically how the computer knows whether you have everything connected to your laptop. So if I go over here, for example, I could try connecting one of these just to show you guys how it looks. So if I connect a joystick, what happens is that there should be something that pops up here. So you can see over here. So after that, we have a large software suite, as you guys can see over here. And again, this might seem very, very detailed, but trust me, once you get into the details, it's really easy to understand. So when you press something and give it a command, the first thing that happens is that we go on this file called a robot. So just by the name of this file, you can tell it's a very basic file, and it's where everything starts from. So mostly in all of our files, Java files, we have something called a periodic. And as the name says, a periodic function has things inside of it that basically happen every 20 milliseconds. That's the complete cycle of an FRC robot. So basically, every command that you run and every log that gets printed or every action that needs to be calculated needs to happen in those 20 milliseconds. And we have periodic functions in pretty much in all of our files, but this is the main example you can see here. So this line exactly is what actually checks whether you get a command. So this line constantly gets called, and every 20 milliseconds it's asking, do I have an input from the joystick? And from there, what happens is that once it recognizes it does have an input, we go to this other file called the robot container. And again, this file looks giant, but that's because it's also been really unorganized, but it still does the same action. So basically, I can show you guys an example over here. So you can look at this line. So once you press something, in robot container, you have to go, it tries to find what specific button you actually pressed. So this one is called right trigger, and that's basically this button on the joystick right here. So as you can see, this one. So once this is pressed, that action gets performed. So one thing, this is something we like to do in our code. We like to name things properly to make sure it's easy to understand what we actually have going on. So what happens over here is that we have two different basically keywords called while true and while false. So that's based off of this whole logic right here. What do you think happens when you press and let go of the button?
It turns into false.
So what happens when it turns false?
That's what happens when you let go.
Exactly, right? So when we press it, then what do you think then, as Tyler said, the intake turns on. But when you let go, then what happens?
Then it stops.
It stops, exactly, right? So that's how we control our intake motion. And as you keep seeing here, we have many of these bindings, and we use some of these keywords to make sure that the robot knows what to do. And we have something, the other big difference that's really important in FRC software when we're trying to program buttons is the difference between on true and while true. And the example I showed you guys is about the indexer, the intake, and we have another one, for example, here, which based on what's said here, it sets the shooter speed to something. So going back to the question I asked before, what do you guys think is the difference between on true and while true?
On true, it's like what happens at the moment it is set to true.
Okay, yeah. And so what's the difference between on true and while true?
Like on true is like the beginning and while true is like during. That's what I can.
Okay. Yeah, no, I see exactly what you're saying, right? Does anyone else have an answer for what
Maybe like while true is like a continuous function, like it continues to happen while it's true, and then on true is like the start of something.
Yeah, that could be a good example as well. Anyone else? Okay. So basically both of you are correct, right? So while true can be considered as a continuous function. So basically the easiest way to explain it in real life is on true. Let's say if I have something that's on true and I press it, and the command for that is making a motor move. Once I press it and let go, even after I let go, the motor will continue to move just because I pressed it once. So it doesn't matter how long you press it, all you have to do is press it once and the motor moves. But if it's while true, then you have to keep holding it for the motor to move. Once you let go, most of the time the command will stop.
I have one thought to add to that. The fact that the motor continues to run after you use on true and press it once is dependent on the command. Really, on true versus while true is about how the trigger is being sent. On true means that the trigger is sent exactly one time, and then the command can do whatever it wants to do from that trigger. And if that means that the motor continues to run, then that's what it will do. But the command doesn't necessarily need to do that.
Yeah, so it also depends on how you structure your commands and what kind of commands you're actually running.
This is also generally why we don't use on true. We try and stick to while true because that keeps the driver in the loop.
It also keeps the driver in control, so they
Right.
feel like they know what they're doing.
If something goes wrong, they just let go of the button and the command will be interrupted.
Yeah, so first we started on robot, and from there we went to robot container, which basically lists all of our commands and how they're connected to our joysticks. So now I want to ask you guys a very basic question. What do you guys think is a command in general? Ariana, do you think you have an answer? Shane?
Oh, like tell them something to do something. Like it's
Exactly.
commanding.
Yeah, that's the basic definition, right? You basically, instead of this time, instead of telling something to do something, we program it to do something. So that's basically the definition of a command. And in order, all of our buttons over here is binded to a specific command. So we can just go to an example of a basic command that we do. So looking back at our intake command that spins the motor in, I can go to where it is on the actual code. So you can see over here. So basically, have you guys heard of functions before? Yeah, okay. So if you haven't, what a function does is that most of the time it doesn't have to, but sometimes it takes in an input, other times it doesn't have to take in an input, but basically it performs an action and it can return something. So for example, as you can see here, this says command. That means this whole function over here is returning a type of command. And if you see a keyword called void, that means it's not returning anything. So for all of our commands, you can tell they have the command keyword over here, and this is an example of a basic command you would do. It just spins the motor and sets it to a speed. So this is an example of some of our basic commands.
Sorry.
No, go ahead.
This is also how we structure our commands. Generally, we want to have like a method that performs the actual function on the motor or whatever's actually happening, and then wrap that in a command. This way, actually looking at the command and being able to modify it is a little simpler.
Yeah, so we want to follow this formatting. But there's also examples of like other more complex commands. So there's different ways of structuring a command. So we can go to another example over here. So as you can see, these are the many commands we have, but we mainly use this one command. So just based off of the name of this command.
That one?
What?
You're gonna show them that one?
I mean, I'm not going to explain the whole thing, unless you guys want me to, of course. But, I mean, basically, as you can tell by the name of it, this is the position and shoot command. So are you guys familiar with the game from last year, or like the game at all?
Yeah.
Okay. Alright, so basically, again, you have a robot, it shoots, the yellow balls towards a hub, right? So position and shoot command is basically, what this does is that imagine your robot is in a random position in the field. So if it's in that position, you need to figure out exactly the angle your turret should point at to shoot accurately towards the hub. You also need to know the motor speed that the motor needs to run at to make sure the ball goes far enough. And along with that, you also have something called a flap that controls the angle as the ball goes out. So those are three independent systems we need to control in one command. So how do we do that? That's basically this command. So for this one, what we do is we have all of these, we have all of these subsystems, which is, it's a different type of file than a command, but basically we use subsystems to create large-scale commands like this. And as you can see over here, we have many different subsystems used in this command. The flywheel is basically the motor we use for the shooter. We have the turret, which is the angle, like the system that angle towards the hub. Then we have the agitator, the indexer, and we have an intake. So we also have the sword thread here as well. This whole thing looks very complicated, and usually, like Isaac said, we don't write our commands like this. But this year we had this very complex command, and we felt like this large file was the best way to execute that command. So here we have something, if we use this format, we have something called initialize. And this is basically everything over here is done at the very first moment when you press the button. This is what happens at the very beginning. And then after that, we have something called execute. And as you guys can tell by the name, this is where all of the main stuff happens. This is where you do all of your calculations, it's where you set all of your commands. And for example, over here, this is a basic command for turning on a motor and setting it to a certain RPM. And if you keep going, at the end, you have something called end. And this is what happens when you let go of the button. All of this runs. So as you can see, based off of what you have here, you have all of these. You have stop turret, you have stop index, you have stop agitator. You have a lot of these stop functions to make sure these motors turn off as soon as you let go. So that's how we structure some of the larger commands, but like Isaac said, usually we don't really use this format, but we have initialize, execute, and then we have the ending function right here.
Right, and the reason why we don't use it is because of how complex and hard to understand it is to look at, right? Because it's not super organized, and I think that's partly because of the time constraints. If we had more time, we probably would make it look better, but it's just harder to manage.
So like I mentioned before, in commands you have things called subsystems where you call like mini functions from. So all of these basic functions like making a motor move or making something lift up or moving a specific amount of rotations, all of those small things happen inside the subsystems. So we can go to an example of one of our basic subsystems. So as you can see over here on the left, these are all of our different subsystems that we had. And we can go to the intake, for example, and we have two subsystems over here for the spinning part, so when the motor actually takes the balls in. And then we have a tilt subsystem that's used for moving the intake up and down. So if I go to the spin subsystem, for example, you can see this is how we structure our subsystem. We basically have to tell it how many motors we're using. And then from there, we go down and these are all of the different actions our subsystem can do. So for example, all of these commands and methods, this is what we call inside those larger commands, and we can chain them together to make a larger and more complex command. So let's say we have to do something. We have to move the intake down, take in some balls, and then move the intake back up. So how many separate actions do you think the intake will need to do if it has to complete those actions? I can describe it again because I think I went really fast. So like, let's say the whole action you want to do, you have an intake, it starts out folded in, you need to make it go out, you need to take the balls in, and then after all the balls are in, you need to move it back up to the same position it was at. How many different actions is that?
Like 3 or 4, right?
Yeah, it could be 3 or 4. Raphael?
5.
5. Okay, what do you think could be the 5 actions? There could very well be 5 because like in the beginning when I started doing software, I'm like, oh yeah, that's just moving it over. But there's so many things we need to keep into account. Do you have an idea of what the actions would be? Shane, do you have an idea? Like the specific like steps?
Oh, well, maybe like, you said it starts folded in, so like folding it out, and then taking it in, and then like putting it back to its regular
Yeah,
spot.
so 3 actions, right? That's what it sounds like. So all of those 3 actions that you mentioned and 5 actions that could also happen, those are small methods. It's like, oh yeah, move a motor to make it go out, then move a motor to make it spin in, move another motor to make it go back in. So all of those like small actions are what we program inside the subsystem, and then we chain them together in a larger command. So a subsystem is like the lowest level of FRC software because this is where we do all of our basic methods, and then from there we can go into the commands. We can bind them in robot container and connect them to the joystick, and from there we can basically call them from the robot periodic. So that's pretty much like kind of the overall gist of like the whole flow of how, after you press a button, what actually happens. I know this is a very long and complicated answer, but in the background, when you're calling something, this is what actually happens.
I will like to add that a reoccurring theme in Java is that things are nested inside each other. There's always a parent, and then something is then being. There are multiple parts to every whole, and it's just a bunch of parts put together in simpler terms. Obviously, it's a little bit more complicated than that, but it's how we structure all our code basically in Java and on the robot. So having a grasp of how that fundamentally works will also help you not only understand how our code works, but how Java is typically used as well, like outside of robotics.
The biggest part about software, I would say, is not even like, you might think, oh, I only know Java syntax, so I can't program, right? But I would say the biggest part of programming is not knowing everything, like all the syntax, or actually even knowing everything about Java, but it's about knowing how to solve problems and how to basically break things down, like Mr. Mike said, and how to make a flowchart of actions. So the question I asked you guys about the intake folding, and that's an example of how you would break a large action down into small parts. And making sure you guys can do that is probably the first step into learning how to program, I would say.
Right, and as you start to learn more and actually start coding a little bit for us, you'll come to understand that like basically what she said, like most of your time will be spent not actually coding, but more of understanding the problem on a deep level.
And to be fair, a lot of the things that you might not know, you'll have AI and the internet to help you figure out. Knowing the details is not as important as being able to break down the problem and figure out an elegant solution.
The solution also doesn't have to be elegant.
Sure.
I mean,
When you're starting out, obviously
well, I
that's
can
what
give you
you're
guys an example. So do you guys see that on the board, all of the pink writing? That's all of the math. So again, that's all of the math I was doing before we wrote this big command. So most of the time, I wasn't even writing the code, I was doing that.
That was
so
like a week's worth of like problem solving.
Basically, so like, as you can see, like, you know, this whole command looks complex, but behind that is like weeks of figuring out how to actually solve the problem. So I don't want you guys to think that you can't get involved in software just because you're not that familiar with Java or, you know, like, or you haven't programmed before, because a large part of it is problem solving. And the last thing I want to kind of end with is, after we went through the subsystems, I want to kind of like spend time like categorizing our subsystems and what kind of things we do. So, I mean, in my opinion, I consider like basically there's 3 different types of subsystems. First, we have the drive. The drive is basically the 4 wheels on the robot and how we make the robot actually work in a sort of drive way. And if you want to kind of visualize it, have any of you guys like, you know, like spent time like spinning in like an office chair, just moving around? I mean, I find it very fun, right? So basically, like, you know, the wheels on an office chair.
Check on Nathaniel's chair right here.
Yeah. The wheels on an office chair, that's essentially a sort of drive. Because you can travel diagonally without having to turn. So like if you have a car, for example, you need to turn the whole car towards the left to go to the left. For a sort of drive, you can just like kind of glide to the left instead of trying to, you know, turn towards it.
Basically turning without turning, kind of.
I mean, yeah, I can say it like that, basically. I know it sounds really weird, but that's kind of
Like you're turning, but you're not turning.
Crab walk.
Yeah, you're drifting, right? That's a better explanation. Yeah, for sure. So that's our basic drivetrain. And then we have all of our, I would say, our motor subsystems. So everything you see, like, you know, from the intake, the shooter, to the climber, the agitator, all of those things are made up of like basically just motors, and you have to tell the motors to move, or maybe move at a specific speed, turn towards a specific position. But those are all motor-based subsystems. And lastly, we have something called the vision subsystem. So have you guys seen the camera on our like robot yet?
Yeah.
The limelight?
Flashbang.
Have you seen it yet? Okay, so I can just like search it up, I think. Yeah, so basically we have limelight cameras. And
So
these
when it's
are,
on,
what?
if we can just pull them up, the robot's on.
The robot's like over there, so I don't know if you can bring it, but I'll show it to you later when we're on
That's
there.
where my dad just went.
Okay. Yeah, so yeah, thank you. I'm glad your dad went there. But basically this is a camera, and you guys, I'll show you guys the AVO tags. I'm pretty sure you've seen these two on the field. They're kind of like large QR codes, and the robot scans them on the field, and from there the robot can figure out where exactly it is. And using this camera on the robot can scan these AVO tags on the field to figure out where exactly it is on the field. And this is very important, especially for, I mean, every year it's important because the robot needs to know where it is on the field. But specifically last year, sensing where the robot was on the field was important for our position command, because how far the turret had to turn and the speed the robot had to move at to actually shoot the ball depended on where it was and how far away it was from the hub. So the other subsystem, we call it vision. This is where basically how we program the camera to receive these inputs and transfer that to the robot, so the robot knows where it is on the field. So those are kind of like our 3 types of subsystems. I would say the drivetrain, and then basic motor-based subsystems, and then we have our vision subsystem. The way I want to end the whole workshop is tell you guys how you can get more involved in programming if you're interested in going into software. So Raphael, for example, you've been doing Codecademy lessons.
Yeah.
Mariana, you've been doing them, and Nathaniel, I know you started as well.
They are
So-
extremely helpful.
Yep.
Yeah, so their Code Academy is basically a, it's kind of like code.org, but I would say a bit better. Sure, I'll pull it up. So these are all of the topics, so then they offer Java as well. So basically, if you do their introductory Java, basically Java skills lessons, then after, I would say after the first couple of lessons, you'll definitely get a lot more comfortable with Java. And if you're interested in programming, I would definitely recommend this. This is something you guys can do in your own time. You don't have to complete the entire lesson to feel like, oh, I can finally get involved in programming, but it's still good to get a basic idea of how Java works, just so you guys, can understand some of the basic, terminology and, how we structure our code. And the other thing I would recommend is we basically organize our code in GitHub. Have you guys heard of GitHub before?
Yes, I use GitHub a lot.
Oh, nice, that's good. So, we basically use GitHub to organize our code, and it's a way to make sure that when we have multiple people working on the same exact code base, it helps us basically organize what everyone else is doing. It helps us figure out what code do we actually want to add into our main repository. It also helps us test stuff.
So basically, I guess I don't want to really get into the technical bits because I guess it can get a little complicated and hard to understand.
So we have this repository, and over here we have, as you guys can see under platforms, Raphael, are you and Nathaniel busy with something?
You're just checking.
Okay, I just wanted to make sure I wasn't interrupting you guys with anything. But basically, on the screen, as you guys can see over here, we have all of the different platforms for the mini robot. You can see Isaac's for code over here as well. But basically, then we have mini Isaac. We have mini Isaac here as well. So for example,
the mini robot.
Yeah, so if you guys have seen the small robots, for example, Mariana, you can name one called Mini Mariana or something, and then you could do your own code for it. So it's very easy to start doing code on
Do you guys keep everything in Visual Studio Code or?
Yeah, that's the main environment that we typically stick with.
But the VS Code we use is kind of a bit different from the normal VS Code. So this is the app we use over here, and I can send this on the Discord as well. But there's a whole installation guide for how you download the specific VS Code needed for FRC. And then from here you can just follow the instructions, and it's very easy to just download it, and then you can get access to it really quickly. And we can also add you to the GitHub as well. If you're interested in being added there, if you're not already added, you can talk to Mr. Mike and he'll be happy to add you guys to the GitHub. So we have the mini robots that you can practice on. And the other thing we are trying to do is we are trying to make a repository, as you guys can see here, called Learn to Code with 3932. And here we basically have different levels of, I would say, software tasks. So level 1 could be making a motor move. Level 2 could be trying to implement PID. Level 3 could go on into the Swarf drive, and then from there can go on into autonomous programming. So we are trying to make this so that newer students coming in can easily go through. It's almost like a course you can go through to learn about the basic tasks we do. So we are doing this right now, and when we finish, we will send it out to everyone so that you guys can go through and work on it. Okay, all right. Well, that's the end of the workshop. Thank you guys for coming. I really appreciate it. Even beyond the workshop, feel free to ask any of us, and we'd be happy to explain it to you guys.
Thank you, Tanzeela.
Thank you.
Thank you.